everyone, this is an introduction to groups with one example. A set G and a binary operation star are said to form a group if the following four conditions are met. The binary operation is closed on the set G. There's an identity element in the set G. Every element in the set G has an inverse, and the binary operation is associative in set G. So, for example, we have this set here. G is 1, I, negative I, and negative 1. And so I did a Cayley table and multiplied this. We're using the binary operation multiplication. So G times. All right. So we have to satisfy those four conditions. So if you look at the table, this table is closed. And that means that no new operations, no new elements appear. So the only thing that appears in the table are these four elements. So that means it's closed. There is an identity element, and that identity element is 1. Because if you multiply by 1, you get back the element. 3, every element has an inverse. And you can tell that every element has an inverse because the identity element appears once in every row and once in every column. So here it is, here, here, and here. So that means it does have an inverse. Each element has an inverse. And for multiplication is always associative. So it is associative. This is also known as a abelian group because it's commutative. It's a special group. And that's because if you look about the diagonal, so our diagonal will be here. And looking about this diagonal, if you look on either side of the corners of this, you get the same value. So from this one we get I and I. From this negative 1 we get negative 1, negative 1. From this one we get 1 and 1. So that means it's an abelian group and it's commutative. So it's a special group. And that's it. Thank you. Have a nice day. Bye-bye.